All right, welcome everybody to today's webinar hosted by the International Solar Energy Society ISIS and by the IEA SHC Solar Academy. We are very pleased to have all of you here. My name is Arabella. I am the Communications and Outreach Officer here at the ISIS HQ, and I will give you a short introduction into ISIS and the work we do. The International Solar Energy Society ISIS is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ISIS represents a diverse membership of academics, researchers, energy practitioners, consultants, students, businesses, and advocates. And ISIS works together with like-minded organizations from countries all around the world to advance the renewable energy transformation. As a special benefit for all attendees of today's webinar, we are very happy to offer you a special discount when signing up as an ISIS member. All attendees of this webinar will receive a 20% discount code as a follow-up to this webinar over the next few days. So we invite you to join our global solar community. Some brief information on today's webinar and especially the Q&A session before we start. You can type in your questions throughout the webinar at any time via the chat box, and we will try and answer as many of them as possible during our Q&A session. When you write a question, please keep the question short and precise, and also write who the question is for, so that the moderator can assign them directly. I am now happy to introduce you to said moderator, Bärbel Epp. Bärbel is the founder and managing director of the German consultancy Sorico, Solar Market Research and International Communications. She's also responsible for the international newsletter Solar Thermal World, which is reporting exclusively about market and technology trends in the solar heating and cooling sector. And for 3 years now, Bärbel has also been the author of the SHC chapter of the annual Global Status Report on Renewables published by REN 21. Now, I'm happy to hand over to you, Bärbel. The floor is yours.
Yes, good morning, good afternoon, good evening from my side as well. My name is Bärbel Epp from Sorico. Thanks, Arabella, for the nice introduction. I am the moderator of today's webinar, and I will give you a short introduction into IEA SHC. And I think I received the screen probably. Thanks, perfect. I will share my full load. Well, SHC, the IEA Solar Heating and Cooling Program, is a collaborative research platform, really huge, with over 300 experts from around the world, from 20 member countries, the EC, and 7 international organizations. We have currently 8 running research projects, and they cover a wide range of topics which are all linked with efficiency and solar energy. It's district heating, PV thermal, solar neighborhood, industrial solar heat, renovation buildings, solar cooling for Sunbelt regions. What we offer as Solar Academy is regular webinars. They are hosted with ISIS. You hear one today, and you find all the recording of previous webinars under this link. Also, we offer videos on the YouTube channel, which we have done with experts on conferences or around Solar Academy webinars. And we offer on-site training available on request by IEA Solar Heating and Cooling member states. And the last trainings were in China, South Africa, and UK. If you want to find further information, please consult our website, follow us on social media. You see the Twitter and LinkedIn links here, and you can use our YouTube channel. If you have additional questions, please contact the Secretariat. Today's webinar in this Solar Academy series is titled Integrated Solutions for Daylighting and Electric Lighting. And Task 61 is sort of IEA Solar Heating and Cooling slang. That means it's the name for the research platform in a short form within this program. So I'm done with my short presentation, and I also want to hand over to the first speaker, which is Jan de Boer. He is a group manager of lighting technology and passive solar systems at the Fraunhofer Institute for Building Physics in Stuttgart in Germany. He is chairing Task 61. So he is the coordinator of this big group of researchers, and he will introduce to us the motivation and key activities within this, what we call Task 61. Jan, it's your turn, please.
Yes, thank you, Bärbel, for this kind introduction. Now I have to get the screen somehow.
Yes, just a second for that. Here you go.
Okay, I assume it's visible. Yeah, it's my pleasure to introduce to you today this 3.5-year work program of IEA Task 61. Let me first of all start with lighting in a little bigger context, bigger picture. We still, like with other resources, see that lighting consumption is still growing, that there is an intensive use of lighting. From satellite images have been deducted that we still see huge increases since 2012. One study showed that we have 2% intensity increase of electric lighting and 2% increase of illuminated area on a global scale, so showing that this is still ramping up. We know, if we are relating it to the energy consumption, that for lighting we need around 15% of global electricity, and also that lighting accounts for around 5% of greenhouse gases. So lighting and energy efficiency definitely is a topic we have to look into. Looking a little into the market, we all know about very efficient SSL systems, LED systems now around, but nevertheless, we are seeing worldwide effects of so-called rebound effects. Low price and very versatile LED systems are being used more and more in parts, compensating the efficiency gains we got. A little on the background of the markets we are in. It's on the one hand side electric lighting. We went through a transition of technology here, around 70% estimate of market volume now in Europe in LED technology, replacing, of course, older technologies. We have an efficiency boost here, LED systems around twice as efficient as the formerly used fluorescent lamp systems. And now the next step in electric lighting is very much into the digitalization of light. So you're getting more features, more functionality in parts for less money. So it's a very dynamic change and transition we are in here currently. The other aspect we're dealing with is the facade, and thereby the facade influencing the daylight supply in buildings. So the facade market, we are having around 1.3 billion square meters of new facade put up each year. That's an amazing number. It corresponds equivalent to the area of the city of London. So that is being put into place year by year. And this, of course, has a huge impact on the daylight supply and therefore the lighting conditions in interior spaces. Generally, we see the trend that we are moving from component development more into system solutions, trying to optimize the integration of different components, and that is bringing us to basically the topic of our working program that we are addressing here, open issues in the integration of day and electric lighting. That is addressing user aspect, it is addressing energy efficiency of these combinations, it is addressing technology side, and also market aspects for industry, but also for design practice. Just to give you a couple of ideas which we addressed in the beginning of this activity to have a closer look into is definitely the side of the user perspective. We are seeing changes in design and control parameters as we are understanding better and deeper that we not only have to meet visual but also non-visual effects. When we're designing lighting installations, we have to tailor lighting systems to different ages of people, of user of spaces, and this of course then has implications that we have different and additional targets in lighting designs. For instance, we might see higher luminance levels part of the time in the future in indoor spaces, that is going along with the question if we necessarily need higher energy demands on consumptions for this, or if we can solve it smarter by, for instance, using more daylight. It has implications on new products, methods, solutions coming up, new control strategies, new luminaires, or also new rating methods we are seeing coming up. Another issue is on the integration of lighting environments in indoor spaces, bringing together the light coming from the facade through the sun shading, through the glazing systems with electric lighting. That has up to now very much been driven from the facade side by solar controls, and lots of studies show that when people are actively doing something on the switching their facades, their sun shading systems, they are doing it for lighting reasons and not for thermal reasons. So the job to get done is to integrate these approaches better and bringing electric and daylighting aspects better together at workplaces. The third issue is on the technology side. Today we know that we are having technically quite many solutions at hand. Almost everything is technically possible, but will that be accepted? So the key question here is the technical complexity also increasing the efficiency. If we're having a difficult design, difficult installation, and difficult use due to not really matched technology, will that be in the end maybe more efficient than something very easily designed and installed and used? So in the end, something very simple could be more efficient and better accepted. So we think that that is worth to look into. Another aspect is on the market side. We are having different industries involved in lighting. That is on the one hand side, of course, classical electric lighting, the facade industry, building automation. And we see in the buildings more and more things, components being connected. We are seeing new function integration, for instance, in facade, not only delivering electric light, daylighting, but also delivering electric lighting. And we think that if we bring these different trades industries better together, we can generate quite some added values. In addition, we have to bring it out into the design processes up to the desktops of practitioners, and also put that in the context of national regulations. So quite a bit going on, for instance, on EU level and on national level, trying to bring down energy consumptions as a whole. Standards are important for that, so we think that it's also worth working on developing standards further, better connecting day and electric lighting aspects, for instance, having methods rating things on an hourly basis. And also important, the improvement of design tools, rating tools that we possibly include the market leader with simulation tools here, closing gaps which are still existing on the daylighting side and on the lighting control sides. So that's another aspect and issue we're looking at. Altogether, we are trying to push the integration of electric lighting and daylighting by using these enablers, better understanding of perspective and new technologies and tools around, and hoping that with our program we can contribute a little to a higher integration of user-centered lighting at a high system efficiency, implementing daylight as sort of a template for electric lighting solutions, and also linking market and industries better. So in the end, hoping to give us little push at least for more energy efficient lighting and damping these mentioned rebound effects. The task structure we have given ourselves is basically on 4 main projects. Subtask A is dealing with these mentioned user perspective and requirements. Subtask B is on the technology side, integrating and optimization of daylighting and electric lighting. Subtask C deals with tools, design support, design workflows for practitioners. And in Subtask D, we're doing validation in demonstration projects, lab and field study performance tracking. That all is cross-connected by two activities, the development of a new evaluation and rating method for integrated lighting solutions, becoming part of an ISO standard, and also going into widespread software, lighting design software, and VR-based decision guide, on which Mark is going to talk a little deeper in the next one of the next presentations. So in the end, we are bringing up results, publications for different stakeholders, designers, standardization bodies, industry, software companies, building managers, policymakers, and hopefully in the end that for the building users we can improve indoor conditions, can support health, comfort, and of course energy efficiency with this program. To just give you a brief idea of who is behind this activity, Bärbel mentioned it. It's a quite big research group of around 35 experts from 14 countries, coming from as well research institutes and industry at the same time. We have publications, early publications out, for instance, a paper, position paper on the use of daylight in non-residential buildings, giving indications of actions eventually needed for governments, NGOs, private sectors. We are having the first reports from the research program now out. More are coming up during the next year as we are in the final year, and also a newsletter being available. If you're interested, you are cordially invited to follow us on the website of Task 61. The publications which are coming up will be available and downloadable from this site. And of course, keep in mind to use light intelligently. So thank you very much.
Thank you, Jan. I think you gave us a great insight into how complex the field of lighting is, which we use every day, even between research and practitioners. Thank you so much. We will have questions at the end. And that's why I can already introduce the second speaker to you, which is Barbara Matusiak. She is head of the Energy and Environment Group for the Norwegian University of Science and Technology and professor of the Department of Architecture and Technology. She is a trained architect, and her presentation today will look into user requirements for lighting environments. So Barbara, please, I'm looking forward to your presentation.
Yes, thank you very much for a kind introduction. Is my presentation visible now?
Yes, it is. Just
yes. Okay. So subtask A, user perspective and requirements.
Barbara,
yes.
Can you please switch to full screen? So turn off the author notifications.
I have a full screen, I think.
Then you need to change the screen. We are seeing your working environment. Yeah, there we go. Try again.
Here. Yes. Yes. So objective. The main objective is consolidation of available knowledge on user activity and time-dependent lighting requirements. The second, set up use cases in specific applications, reflecting typical temporal changes in the usage of these interior spaces. And at the end, aggregation in so-called personas as representations of the behavior of a hypothesized group of users. We have to remember that the electric light is human-made and is associated with advancement in science and technology. Obviously, humans have perfect control about all the parameters like intensity, distribution, and so on. And contrary to this, daylight is not man-made, and it's not possible to control in any way. So we have to keep in mind those two light sources are very different, but at the same time, our visual system has to function well with those two sources all the time, mostly all the time. So we are keeping in mind those two very different light systems, working with, first of all, lighting requirements and use cases, and after with personas. We started, and during this presentation, I will show you some highlights from the first part, and it is very much based on the literature study and results from ongoing research project. So lighting, what is lighting quality? It's not that easy to formulate. So the present definition is that it is a concept that allows excellent vision while providing high comfort. But this definition of lighting quality focuses on humans, but it does not take into consideration aspects of light that has non-visual impact on human health and well-being. So in addition to those traditional issues like visual perception and comfort, we added also psychological effects, meaning well-being, and non-visual effects. So what we learned so long from the research studies? Visual acuity. About visual acuity, we learned that in recent research strongly suggests that amount of light affects children as they grow and determines whether they will develop myopia or not. And myopia, or short-sightedness, is the most widespread visual disorder affecting young people. It has reached an epidemic level in Asia, and it is increasing everywhere. So some studies refer that the risk of myopia is lowered by exposure to daylight and increased by activities performed at short visual distances, so close-up work. A person with little exposure to daylight has a 5-fold risk of developing myopia. What we learned about age? The visual recognition of object shape is different from haptic recognition in multiple ways, and visual shape recognition can be superior to that of haptics, and it's affected by aging, while haptic shape recognition is less accurate and unaffected by aging. Even though some researchers suggest that middle-aged adults' abilities to perceive and discriminate three-dimensional shape from motion are rather similar to those of young adults. So the negative effects of increasing age on 3D perception do not become substantive until the age of 65, 70 years. What about emotional status? Yes, since visual perception is an active process, emotional status matters. Happy participants can judge the room to be brighter than sad participants. And we found cultural differences, especially regarding the color temperature of light. In some experiments aiming to investigate the effect of lighting on the perception of the atmosphere in a room using 3 types of light sources, a higher color temperature source would make the room livelier for Chinese observers, but less lively for Dutch observers. Flicker may be divided into 2 types. A visual flickering light can be detected by the eyes, and subliminal. So the flickering light is not consciously detected, but the brain is registering the flicker. And flickering lights can be uncomfortable to look at and can induce seizures in observers with photosensitive epilepsy. Subliminal flicker may cause headache and impaired cognitive performance. Glare. In a semi-controlled study in a test room with direct access to daylight and an external view, the researchers detected a tendency toward an increasing tolerance to discomfort from daylight as the day progressed. It seems that glare sensation from electrical light also varies with time of the day. A laboratory study showed a tendency toward greater tolerance to luminance increased in artificial lighting as the day progressed. Additionally, the time interval between the sessions matters. The temporal variation of glare response was found to be also influenced by the difficult extracting information from the visual stimulus. Moreover, statistically significant and substantive evidence was detected of a direct effect of fatigue and caffeine ingestion and an inverse influence of food intake on reported glare sensation. The factors that almost certainly do not influence discomfort glare perception are the gender and optical correction. What about contrast? The human visual system is more sensitive to contrast than to absolute luminance. Therefore, humans can perceive the world similarly, regardless of the huge disparities in illumination levels over the daytime and space. In one study,
you have 2 minutes left. Thank you.
Okay, facade geometry and associated sunlight patterns have significantly influenced on the subjective responses. So analysis showed differences mostly between the irregular and regular pattern, with the former being evaluated more positively. And it had also impact on the heart rate. Contrast can be measured by luminance ratio, and we can look at spatial frequency. The visual system is optimized to encode images on natural scenes. So one source of visual discomfort is when images have spatial frequencies that deviate from the spatial frequencies typical for natural spaces. And then we can look at behavioral effect of light, how people use and what sort of lighting they prefer. And we can just again repeat probably that people should have access to windows giving the view because of information, restoration, and aesthetical issues. And the window size should not be limited, not only because limiting of the view, but also because the window size had the effect of spaciousness, openness, pleasantness, excitement, and legibility and coherence of the room. So I have also a quite long series of information about non-image forming aspects. Maybe the most interesting is that there are differences related to chronotype, age, and gender. There are also changes in chronotype over time. Girls and women seem to be significantly more morning-oriented than boys and men. Young children are more morning-oriented and become rapidly evening-oriented during the puberty, while the more attenuated turn toward morning lens occurs from the age of 20 years, and it's more stable. And elderly people display a high risk for disturbed circadian rhythm. So, based on the literature review and results from ongoing research projects, we are proposing the recommendation of daylight and electric light for the first time in one publication and in one very long table. A part of the table you here, so we have daylight and electric light, and for example, workplace illuminance in general, how what are recommendations here, and for electric light as well, for visual demanding, and so on and so on. So I just recommend, for if you would like to know more about human needs and recommendations, so the report A1 that we call it, will be published very soon, probably already in October. Yes, thank you very much.
Great, thank you, Barbara. Very impressive, very nice to see lighting and health being linked by researchers and even looking into gender aspects. Thank you very much. Well, our next speaker is Mark Fontoyont. He is professor at the Danish Building Research Institute at the Aalborg University in Copenhagen. He is a real expert on new lighting techniques, and he will share with us today his insights in simplified maintenance and improved user friendliness of these solutions. So please, Mark, the floor is yours. And maybe before you start and to get your presentation ready, I want to tell to everybody, you know, slides, presentation, PDFs, and recording will be available on the IEA Solar Heating Cooling Solar Academy webpage. And so this was asked several times already in our chat. So you're free in a week's time to consult there and either listen to the recording or download the presentations. So sorry for this intervention, Mark. It's your turn.
So, thank you, Babel, and I hope that you see my slide and you hear me, right? Do you
Absolutely.
confirm?
Yes.
Okay, thank you. And thanks very much to Barbara for this introduction, because we should never forget that the lighting is for humans, the way we approach it, and there is a value for all of us. So I would like to talk about technology now, if I can access my bar and move forward. Yes. So everything that Barbara described, the issue is we have to bring light, the light we need, the way we want it, when we need it, and we have to do that with electric lighting and daylighting. And we have to do as much as we can with daylighting, but we have nights and we have to do something else at nighttime. So up to now, as Jan mentioned, the energy, the lamps have progressed very much in efficiency. And in this global narrative, the next step now is really what to do with it. I mean, we are really now using light sources at 150, 180, 200 lumen per watt. We're getting to the point where this progress is not much possible. So what we do, we have with a group of experts in this subtask. I would not cover these here, but we're preparing 5 reports, and I'm going to talk a little bit about the contents of this report. One is on the survey of what are the market, what is happening on the market, and what is expectation on the market for the controls. The second is a review of technology, a critical review and analysis. The third is an identification of new products coming. What are the researchers doing in the laboratory? What are the companies preparing? What is happening in this field, and what will be available in the next few years? The fourth report is about the interfaces, the way we communicate with the system, and there is a huge progress on that, both in the software but also in the terminals. And the last point is, of course, the relation with standardization. There's a demand to have standard solutions because it's such a versatile topic. On the survey, we have questioned a number of professionals in different countries, which were mostly, I would say, building owners, managers, companies like that, to express what they were expecting from these lighting controls technology. And I will just summarize just a few results now that came out. Of course, the first demand is they expect a significant reduction of electricity consumption on top of what they are using now. That's a big driver. But they also ask for more robustness, long warranty. They are facing a number of issues of maintenance. The commissioning, which is the installation, is a big issue. They expect standardized solutions because the supply is very versatile. The investments and running costs should be perfectly on hand. They expect simplicity of operation. possibility of override, which means not to depend fully on the controls and automatic solutions. They want some more task ambient controls, glare control from windows, and Barbara mentioned that before. Concern about well-being of occupants. Can control help the occupants to feel better? And future-proof solutions. If you invest today in systems, how the system will perform in 5-10 years. They expect also compatibility with BMS, building management system, and also wireless, which is attractive because this means less wiring for installation. We are reviewing system. I don't want to cover all that. I know some of you, or most of you, are expert in that. So you know the supply is impressive from centralized system, closed loop, open loop, the type of sensor you're using. We're reviewing also the market structure, depending if it's residential and non-residential, which are very different markets for the application. And you have drivers like in individual buildings, very much related, for example, to security issues. Often it's much more related to heating problems, overheating, whatever, and lighting is just a second aspect. So it's hard to really fully link the control technique to only lighting quality. It's a bit more global in buildings. We also see movement changes, a lot of protocols of communication, and this shows that lighting control is part of a more global system. And often if you have a very well developed BMS, the lighting control is only part of it and could be cheap with few sensors. So you have a whole range of control for fully dedicated to lighting to completely integrated in BMS. And now with the data architecture coming in the buildings, now the data system like the PoE, Power over Ethernet, can even light the lamps. We have two IEEE standard on this PoE 100 watt system, and also the single pair approach, which we expect will also put price down for controls. We see some initiative for DC powered lamps, 48 volts, which allows transformers to be centralized and not from every light source. New sensor system and chips with geolocalization can really adapt lighting to your area. I don't want to go too much into all this new proposal of architecture. It's moving. I think some of you are probably involved with photovoltaic systems, and photovoltaics produce these DC current, usually rather high voltage, but there's a number of actors that think that part of the building could be powered with DC power. And we have also pushed from the companies working for the automobile industry, with especially the electric cars, with components that may move to the building from the car industry. So we're checking that very, very important evolution which is happening. We looked at a number of performance criteria of all these systems which have the protocols with the advantages and drawbacks. We also look now the future trends, and the future trends, we have an analysis based on the value creation over that. Part of this lighting control system are basically solving problems today, and part of them are also creating new values, new functionalities, new opportunities to run this better. So this is something we have absolutely identified, and it's impressive to see how the market is pushing for development of new systems in a global manner, and having a little bit like a talk recently with the people working in the car industry and the electric car industry, which is very much driven partly with by software development. And you could see now that also software is moving to this lighting control business to make things versatile, practical, remote control, flexible. I have a number of terms here, and that's something we look at it, and we report in our next report on B3 and B4 actually. We are covering user interfaces, which is impressive what is happening. We have the classic analog controls, the switches that you all know. Now you have more and more digital aspect, which are on screen, could be on the wall, it could be on your smartphone, on a tablet. And we see also mixed hybrid system where you can mix control while turning or having a physical interaction, but also having party to communicate with colors, whatever. It's impressive what is happening in this domain. And I think it's very creative. It could simplify the world, making a global management of, let's say, buildings, hospitals, schools, commercial centers, or your home more practical, but also we're very concerned by the robustness, the simplicity, the commissioning, the maintenance. Components are progressing, are being shared, and we check the trends on that. We try to really look at what are really the system doing for energy savings, because the motivation often is very far from purely energy saving. So we want to inform the readers about the potential on that. We see something which is not so developed, the combined control of lighting and daylighting is not really the big heart of this development, but we try to grab the system that allowed to do the two. And we look at the evolution of motors, of shading systems, and the way, or electrochromic glazing, and the way they could be combined with the
Mark, you can come to an end.
Oh, yes, an end. I thought I didn't hear the 2 minutes warning. So sorry.
Yes, this is now the 2 minutes warning. Yes.
I see 2 minutes warning. That's good. Thank you very much. So I'm continuing just the very interesting interfaces, whether they are a niche market or they will be dominant. It's really on the target, and that's what we are discussing. We have global issues regarding that. We to finish this document about the lifetime. The model of lifetime is very important because we are talking about system with a different life, which is the control as a life, the drivers have a life, the lamp as a life, the luminaire as a life, and we are addressing this in the report too. And finally, we have a report on standards, because there are relevant standards, there are new standards being developed, and also we identify needs for new standards. I wanted to say 20 seconds on the Jonwa group. We're developing also a number of functionalities to show and communicate about the lighting controls, the way they work, and we collecting data from the case studies. And I think I will have, if I could play this on my screen here. I hope you can see that on my screen. Do you see my screen? I hope so. Maybe not.
Yes, no, we see your screen, yes.
You see your screen, okay. So you see, you can vary the daylight in the room. We have different lighting scenarios. You can play up and down, and you can simulate actually graphically a number of lighting control systems. And we plan to have a number of lighting control systems being demonstrated on the website of the IEA Task 61. Okay, this is where we are now. 5 reports. Some of them are coming soon, and we hope you will be delighted to have them and review them. Thank you very much.
Mark, thank you. This was a very engaged presentation and very impressive work. I think it might be 500 pages of technical insights on new lighting technologies. Very well done. So our next speaker, I welcome Dr. David Geisler-Moroder. He is project manager and head of competence field daylight in the R&D department of the Austrian company Bartenbach. So we switch now to a more practitioner-based speaker. His topic today is design support for practitioners related to simulation workflows and daylight systems characterization. So please, David, the floor is yours.
Well, thank you very much for the introduction. I guess you can see my screen. So as
Yes.
Barbara introduced, I'm also responsible in the IEA Task 61 for what we call the subtask C, where it's about design workflows and daylighting system characterization. So what is this subtask C all about? It's basically we are trying to bring things that are developed technically and in terms of software and in terms of new design workflows and design strategies. We trying to bring them more towards the practitioners, towards their workplaces, to really give them something at hand they can work with in their daily work. So we have four subtopics to what we are doing here. We started with reviewing currently used state-of-the-art design workflows. So what are standardized but also used in practice, which kind of workflows are out there. A second topic, daylight system characterization, is a hot topic, as the daylighting systems are hard to be introduced in daylighting simulations. And then we have two further topics which I will not cover today in my talk, spectral sky models, which closely ties up with what Barbara already mentioned in the first talk, talking about non-visual effects, non-image forming effects of lighting, and then an hourly rating method, which is developed also in this connecting joint working group. So I'll give a short overview of the design workflows and the daylight system characterization topic. For the design workflows, what we did in that state-of-the-art review, we first defined example design projects to give the reader an overview of how such systems, how such buildings, how such architectural designs can look like, and how the lighting design with integrated solutions for electric lighting, daylighting, and controls to look like, and what different applications can be. So we have three different and very nice examples in there. It's our R&D department here at Bardenbach in Aldrans. We do have the office building from Dial in Germany, and the building of the Chinese Academy of Building Research, the Net Zero Energy building in Beijing. In a second step, we gathered inputs from different groups and different people joining the group about the used workflows in practice, as well as proposed workflows in standards or from public entities. So we, for example, have workflows that we use here at Bardenbach. We have workflows that are used e.g. by Norconsult at Inform Design at DL. But we also have workflows described that are standardized in the ISO standard 16817, or, for example, proposed by the German LITG in their scope of services. As today, all design process and design workflow is tightly connected to simulations, which are either for evaluation in the end, but also often in the design process. If we think of parametric design, for example, are an important mean of design nowadays. We also took the time and compared and put them next to each other and checked the different features that design tools provide. So there are quite a number of software solutions out there which can be used for designing daylighting and electric lighting solutions, and also the controls for these integrated solutions. And we did that for different aspects used in the design process and which are necessary for the design process. We summarized general information, which kind of user group can be or is addressed with the one or the other tool, in which design phase they can be used, and so on. So we put them next to each other and got a nice overview of the current situation in terms of software solutions. All that is put together in a report that is already published, that is already out there for all who are interested in more depth. It's more than 100 pages information about the currently used workflows and software for the design of integrated lighting solutions, how the title of the report is, and you can find it on the webpage of the IEA Task 61. My second topic that I would like to dig into is the characterization of daylighting systems. If we talked now about the simulation capabilities, there are some tools out there. They are already working with so-called BSDFs, which are a possibility to characterize daylighting systems in simulations. So quickly talking about BSDF, what is it? If you compare the images on the left and the right side, they basically show the same lighting distribution in the room. The only difference is that on the left side, the facade system, the Venetian blind system that is in here, is represented by its geometry and its material characteristics directly. And on the right side, the overall fenestration system is represented by its BSDF. So it's a possibility to have a representation of a daylighting system that can be used in simulations. As the concept is not new, the concept is has been out there for quite a while, but the way into the mainly used simulation software is still not yet that far. So there are software systems out there that can use data like that, but there is still work to do to really have it in the wide application for practitioners. So if we think about that, why do we need that? If we think about a very different area, as an example of cars, there's the certificate of conformity, which exactly describes how the technical characteristics of the car are. We do have the same for electric lighting. We do have IES or OILUM files that describe exactly the lighting distribution from that luminaire that we have. And the same thing we do have with BSDFs, but we don't have a real standardization and a real standardized format for these kind of data yet. The other thing is what I also mentioned, that we do have for electric lighting quite some simulation tools and quite some possibilities to do proper simulations. For daylighting systems, there are still quite some questions, and it did not find its way into the widely used software systems yet. So what did we do within the task so far? One thing we did is a sensitivity analysis to find out what is the necessary resolution of these kind of data sets for different kinds of systems and different kinds of applications. So for example, if we want to do an illuminance calculation, finding out the overall lighting inside the room, we will need some other representation than, for example, if we want to do a glare calculation, which is based on the luminance distribution directly seen at the window. So we did a sensitivity analysis on that to find that out for different kinds of systems, for blinds, for fabrics, for clear glazing, and so on. And the overall aim is then from that to derive what is the right and the necessary kind of data set that we need for the different kind of systems. So for example, for transparent systems, for redirecting blinds, for these kind of micro shades, for fabrics, for textile roller shades, and so on. And this is an important step towards bringing that into the practical work, as we need to inform industry as well which kind of data sets and which kind of resolution they should provide to the designer, that they can properly include the systems already in the design phase and do the proper simulations for any application they want to show, may it be illuminance or glare calculations or whatever. So what our aim in the end is that we come up with a proposal for different classes of systems. So this is now work in progress. We do have, for example, I took out this example, diffusing general Venetian blinds, which are widely used, especially in Europe. As I mentioned, for different tasks, for different metrics that we want to evaluate, we will need different simulation methods on the one hand, and these are then tightly connected to which kind of data sets and which kind of resolution of the data set we need to put into that model.
David,
So
your 2 minutes are now starting.
That's good. There are 2 more slides to go. So this is work in progress. We're putting these kind of tables, this kind of information together for the different classes, for different typologies of daylighting systems. So as I said, this is currently work in progress is with the experts in that IEA Task 61 are joining here. We do have quite a number of active participants from all around the world, from the USA, from Switzerland, from Germany, from China. They're following partly different approaches in the way they measure, in the way they generate those kind of data sets. But in the end, we are trying to put all these together to propose a good way and a good working possibility to come up with these kind of data sets and propose to industry which kind of data sets for daylighting systems to bring these kind of data also on the places of the practitioners. So we are currently working on this white paper. It is in a quite good stage already, so it will be released soon. We're currently having our IEA meeting in parallel, and we are discussing the last changes to that white paper. So stay tuned; it will be online on the Task website as well. Very soon you'll find it there. So let me at the very end thank our funding agency here in Austria for also supporting the research that is behind that activity. And yeah, I'll give the word back to Bärbel. Thank you very much.
Thank you. Yeah, thank you, David. Very nice insights. I think very valuable work for practitioners, from practitioners, very highly appreciated. We come to our last presentation, which is actually a tandem one. So we will hear Nico Chantile and Verna Osterhaus. They share together one of these subtasks within Task 61. Nico will start. He is assistant professor at the Institute of Architecture and the Built Environment at Lund University in Sweden. And then Verna takes over. He is an architect, lighting designer, and professor of lighting design research at the Department of Engineering at Aarhus University in Denmark. They both will focus on lighting system in health environment and offices. So please, Nico, go for it.
Yes, thank you. It will be Verna driving the presentation. And yeah, Nico Gentile here, Lund University, and I will give you a brief outline on the work that we are doing in the case study. Werner, if you can switch to we have the presenter's view here. Then Werner will speak a bit more about some of the techniques that we are using to evaluate case studies. So here in this project, we are working in 10-15 experts worldwide. We can go to the next slide, maybe. And we are working and trying to present and evaluate exemplary projects of integrated daylight and electric lighting design, projects that for some reason are peculiar, special, and that could serve for as an inspiration for architects, designer, practitioner, and lighting enthusiast. What you should expect to see at the end of the task next year, it's hopefully a number of fact sheets written in quite popular way, like the one that you can see here, where we report on the case studies we had, some evaluations and lessons learned. And then, of course, we'll have references if we want to see more in-depth details about the case studies. But how we are looking to the different case studies? Well, we use a coherent framework. Next slide. A coherent framework, it's a monitoring protocol. Right. Yeah. Which is, I can't see that.
I can't get it to move to the next screen, so I'll have to see whether I can. Now it's going.
Yeah, now it is. Thanks. So we try to look at these case studies by looking at 4 aspects of the project. For all of them, one is, of course, the energy for lighting, which is the main focus here. Then we look at something we call photometry, is basically a characterization of the daylight and electric lighting project. So daylight factor, daylight autonomy, luminance profiles, and so on. But then, very important, we look at the circadian potential of the space. And we look at that different ways. It depends a bit on the case studies that we have in front. And finally, since these 3 aspects are basically measured with technical instrument, we also look at something that is more observed based. So we have user perspective by means of chats, surveys, questionnaires with users, and then we try to give a more complete understanding of the space. We apply the same concept to all the case studies, but we use different techniques to address these 4 aspects in the evaluation, depending on which is the focus and the peculiarity of the case study. Which are the case studies then? We have a long list here. It's a bit dynamic because we are looking at real occupied buildings. So in these times is sometimes a bit difficult. So there are projects that are coming in, some that are going out. But in general, we have a quite nice geographical widespread here. We have an overrepresentation of offices, but we also have healthcare buildings, educational buildings, some living lab, some retail sector. And we have a number of solutions that have been used here and that you will see. And it's, I don't know, daylight harvesting system, open loop, closed loop, granular lighting controls, electrochromic glazing, some special shading devices, low-cost solution in listed buildings, and perforated facade, and I'm surely forgetting something. But interestingly enough, one of the solutions that is more used in the newest building and newest projects that we have is integrative lighting. Integrative lighting, it's a lighting system that are able to change in intensity and color throughout the day in order to support the circadian rhythms of individuals. And how do we evaluate that? We have different techniques, and one of those is to try to log the individual intake of light in terms of both intensity and spectral power distribution. And this is best done with wearable devices. In some projects, we were able to get that. Verna, in particular, could test different devices that are now available on the market, and it will provide some lessons learned and experience by using different devices. So, Verna, the stage is yours.
Yeah, hello. I'm going to talk a little bit about these different wearable devices that we have investigated. We do this to link people's well-being with the integrative or circadian lighting in order to understand what people are exposed to during a particular day and how that might support their individual well-being. And this has to do with both the visual, non-visual aspects of lighting, but also some of the emotional aspects. So during the day, a person is exposed to different lighting conditions, whether it's at home or in the office or anywhere else outside in the buildings. And we need some dynamic measurement methods in order to evaluate that if we want to measure the personal light exposure that a person experiences during the day. What do we need in order to understand that exposure? Because the spectrum changes depending on the lighting conditions, we will really need to understand what the spectrum actually is of the light source, how that spectrum contributes to our health and well-being. We also measure the photopic illuminance, the normal lux levels that you would measure at least, and we try to understand the different wavelengths if necessary as a compromise if we can't get the full spectrum of any particular light source. And we want to correlate those photometric measurements with other human factors, for example, activity levels of people, to see whether it helps them sleep, for example, or if they're awake all night, or whether they can be energized in an office by a particular lighting system. We have looked at a number of commercial devices that we have tested in various of our experiments, for example, the Philips ActiveWatch, the Lys button from Lys Technologies, and the MovieSense light sensor. You find some links to the different websites at the bottom of the web page. And we've also looked at some research devices like the Dacimeter developed by the Lighting Research Center in the US, or LuxBlick, which has been developed by people in Switzerland and Germany. We do believe that there are others out there as well, but we have used the ones on the left side, and the other ones are not available to buy, although sometimes people are allowed to use them for short research projects. I know Nico's group in Sweden has used the Dacimeter for a short period. The Philips ActiveWatch Spectrum Plus is a little thing that is worn at the wrist. It is also a clock, and it does track through the little light sensor that is indicated here the activity, some sleep and wake patterns, the photopic illuminance, and the red, green, blue channels of the light sources. We did use this for some projects, and also other people, for example, at Mark's group in Copenhagen, they have used ActiveWatches, 48 of them, and have found that the calibration needs to be device specific. It does not come with specifications or calibrations from the manufacturer, so we really need to look at that. We have done some very quick tests here ourselves. One of my master students got involved in that, where we had a reference spectrophotometer that was measuring the lux levels as well as the ActiveWatches. And under certain daylight conditions, they were reasonably close together, but much lower than the actual calibrated sensor. And then at nighttime conditions where we had only red and green light, in a psychiatric hospital where we wanted to avoid exposure to blue light to get people to sleep, we essentially did not get any useful information out of that. So we need to be careful with some of the measurements that they can actually do. In relation to activity and sleep analysis, you get some graphs out of the ActiveWatch in terms of the actual intensity of the activity, and then the program software suggests some period where it is actually sleeping or resting, and indicates that. But it's not very reliable because you often need to combine it with some other information. And one of the examples that we had, for example, that a person was sitting on an exercise bike for quite a while, actually almost 3 hours, and moving with every body part but the wrist that was actually holding on to the handlebar. And only because of one of the nurses observing this person for quite a period of time did we know that the person was not sleeping, which the software had suggested, but that the person actually was on the exercise bicycle, but the hand was not moving because of being fixed to the handlebar. Another thing that we use...
You have your 2 minutes left now. Sorry for that.
But I don't know. Okay, yeah. And we use the Lys button, another tool which allows us to track similar things, which is much smaller and it is closer to the eye. But again, we had some issues with reliability. They were very sensitive to orientation. And you can get on your screen on a mobile phone a light stimulus, which we don't really know what the value shows. If you want to get more data out of it, for example, the RGB and infrared channels and color temperature, you need to buy quite expensive software, which is used for that. And we can also see that the calibration of these are rather difficult. Different Lys buttons measure very different levels. And if you turn them around on your shirt or something like that, you get very different values again. Color temperature is one of the good things with that. They're rather close. And in terms of activities, it measures something in relation to acceleration, which is expressed in G figures. The movie sense was also worn at the wrist, and it covers photopic illuminance, color temperature, activity level, sleep-wake patterns, and the temperature. And there we also compared it with the loose button, and they were quite different, although theoretically they should measure the same kind of activities. And when you try to link it with your activities actually and what it's recording, it's a good idea to also have a diary that you write down what you were actually doing at the particular time, because with the movie sense also being worn on the wrist, this can be quite misleading at times. So some of the problems that we've found in there, that they're not always reliable light measurements. Marquardt et al. Have found that the differences can be up to 60% for the same exact type of ActiWatch. And that matches quite well with our experience that we have very large differences between the same type of equipment. With wrist-worn sensors, it does not match the light levels that the person actually receives at the eye. And there were also some around 27% differences between what is recorded at the eye and what's recorded at the wrist. And while some sensor manufacturers claim scientific validation of their products, but they stop communicating when you ask for some of the details. So that's a bit tricky to actually confirm that. So what do we recommend? If you can, use more than one type of measuring device and compare the results. Try to calibrate all the instruments before you use them against a calibrated sensor, because it's not supplied by the manufacturers. But as researchers, we would be very prepared to work with the manufacturers on developing some procedure for that, but that may increase the cost of the devices. We should select sensors which are closer to the eye and facing the same way, rather than things at the wrist, which might also be covered by clothing at times. We should try to combine measurement data with observations or diary entries, and we need to be extremely critical when looking at the results that we get. So avoid making conclusions based on some data which may be questionable unless you can confirm it with some other aspects. Thank you very much.
Perfect. Thank you. Well, we got a lot of interesting insights, and you did incredible work in doing reports, which will be soon all available on the website. Thanks for that. I will start with the Q&A session now. And I think I have the first questions for Jan. One of our participants wanted to know the previous numbers for global electricity use by lighting has been reported to be around 20%. Is the decrease connected to more efficient system or just a new estimate?
As I know, it's to a new estimate. It's not to efficiency, as we've shown I think on the second slide. We are still seeing quite an increase in lumen output, so to say, and also in the area lit. So the number actually is going up, but yeah, so that's just basically you're getting certain corridors for this estimation of total electricity consumption worldwide. Those are estimates and no really fixed numbers, just due to the statistical processes and the data sources these estimates rely on.
Okay. Another question returns to business models to get these new technologies, especially into larger complex buildings, you know, like offices. What experiences do you have with that? Like leasing, or what is the trend there?
Could I try to respond to this question?
Oh, absolutely, yes. That was not fixed to any speaker. Absolutely, yes.
Okay. The business case we have, if you talk about non-residential building, is we know that lighting consumption is of the order of 1-2 euro or let's say, per square meter per year, and savings, it's of the same magnitudes. And the business case today is very much, we have two business cases which are appearing. One is to bring lighting as a part of a global service, including data management into the building, and that pushes for solution using power over Ethernet, for example, because it's the business model of data and other issues per square meter has a much higher value than lighting. So lighting hooked to this business case, right? The other is more towards, in relation to the former presentation that by Verna, Nico, and Barbara, is providing something more appealing, more attractive. And here we see that into commercial centers, hotel, restaurants, as a kind of added value of control for effects. I don't know if I really answers the question on business case, but that's something I wanted to mention. Oh, the leasing. The leasing is experienced by a number of companies to sell light as a service and not light as a product, which means to put together the maintenance, the electricity, a number of things. This makes sense. But once again, it's probably more into the global services to the building. What is interesting with the IoT, the Internet of Things, is you can really know how your lighting works remotely through the internet, which means you can provide your service to can do a facility manager, and that some companies are doing that remotely. So I know some cases in Africa where they are managed in China, for example. If you have a company expert in a control system, they can manage buildings all over the world. And that's another business case that we'll have to look very closely.
Thank you, Mark. Very nice feedback. David, there's a question for you. What about the new software Climate Studio for Solema? What's your opinion about that?
This is definitely something worth looking into, and the Climate Studio, as it has been released quite recently, it's not mentioned in that report, but as Climate Studio basically covers what was formerly Diva for Rhino and Alpha, so that is combined in there. To my knowledge, they are both covered in there. So Alpha, that will be in the report on the spectral calculation, where we, as this is a special tool for spectral simulations towards the non-visual effects also of lighting. And Diva for Rhino, that is covered in our comparison on our software comparison. So definitely something to look into, and this is one of the good examples of how dynamic and how much work there is and how much progress there is really going on at the moment in the field of simulation software for this field, for this lighting of integrated lighting, daylighting, electric lighting, lighting controls. That we see coming up these software systems. So definitely worth looking into that software if people are looking for what to use.
Good. David, also for you, do you know roughly if shading manufacturers are ready to provide BSDF data just like lighting manufacturers do?
To my sense is you cannot answer that easily with yes or no. There are some shading manufacturers out there. They are starting to provide these data, to generate this data. We do have one company also in the consortium here, so they are up for doing that more and more. But one thing that is very important, and where there's still work needed to do, is to come up with ways to generate BSDFs for a huge number of different variation of systems. This is something where there is still one or two steps to do, I would say it like that. If we think of fabrics in different kinds of openness fraction and colors, it's not possible with the methodology that we provide now to really spend it's quite expensive to spend that money for every single variation of that system. So there's still some work to do. We are also working together with manufacturers. They often take it as a chance as soon as they are asked from designers, from architects to provide BSDFs. They go the next step and provide these data for these systems.
Okay, thank you. We have a question related to Barbara. It says, does or how the recommended window sizes take the thermal heat and cooling aspects into consideration?
It's a typical dilemma, and especially for self-orientation of windows when the heat load is very high. But then we have to consider that daylight is not stable. So you have days with overcast sky where you exactly would like to have as large windows as possible, and you have sunny days where you have to cover most of the window because of overheating. So it's two opposite goals, and each time in each project we just have to balance those two and find the best solution. And of course, movable solar shading may help because then you have this flexibility. You can cover the window or you can uncover it. So there is no one single answer on this. And in different projects and different countries, the practice may be very different. We are now in Norway discussing the building code when still there is possible to use a very, very old rule about glazing area compared to the floor area that should not be very high, and it is recommendation about 10% only, and it's very old and not good enough rule, because nowadays you have many layers of glass and you have thicker walls and so on and so on. So the minimum should be more 15% of the floor area, but still this is yeah, as I think it's not any fast answer for this.
Okay, thank you. We have one participant who challenges more or less all the speakers by saying that the focus was too much on controlling lighting, but too little on energy efficiency concepts. Who feels involved in that and wants to answer where efficiency comes into play when you look into your designs and tools and everything?
Maybe that's for Jan, but I can try to.
Yes, I mean,
I think Jan, you should introduce, because you were at the beginning of this task. So this is a question for you, I think.
Yeah, maybe I try to give an answer. I think we stressed it. Several of us stressed it that first of all we have to get user aspects right. We're doing, as Mark said in his presentation, lighting design, of course, for humans, and as we have seen throughout all the presentations, there are quite some new findings. For instance, on the melanopic aspects of lighting we supply indoor, and that has to be sort of brought into this whole process. Nevertheless, we're with the International Energy Agency, of course, and lighting has seen a huge efficiency boost by the LED technology, which has advanced quite strongly, and also the control systems, I think Mark has shown it, still offer big potentials in occupancy sensing, turning off the installations when they're not used. So operating lighting more efficiently from the energy aspect, but while people are in the spaces, we have to make sure with these efficient systems, LED systems, efficiently laid out to meet human demands. And also what we are of course looking into is the facade and the daylighting aspects. So replacing the use of electric lighting by sound use of daylighting. So that's the general principle, and we're trying to prove that in the case studies. They are looking at the energy demands. We're trying to further develop, as we indicated, the design tools, and we're trying to bring it into standardization, which is then also can be used by practitioners, like the ISO standard we mentioned on energy and daylighting, combining it with electric lighting. So you actually in the future have the chance to bring these more efficient technologies in your daily design process and practice, which you to a certain extent cannot do today unless you're going to big climate engineering companies who have specialists on that. So that's bringing it more into the bigger market. So that's maybe my answer to that. Maybe Mark, David, Verna, Nico, Barbara, you want to add on to that? I think it's an important question. Yeah.
Yeah, I think this is a good point, because it's really brings us to the creation of this task. And we know what happened with the deployment of compact fluorescent lamps and the early LEDs, that we had beautiful energy efficient solutions, but actually they could be rejected for a number of applications by users, by facility managers. And we have the same issue now. Now I think the LED market is quite mature. We have high quality, and we don't have always high quality control systems. They don't do exactly what they are supposed to do. Some people may want to override them. They want priority. There's a number of issues. And the success of control systems is partly related to the ability of this control system to be accepted and even desired by facility managers and occupants. So that's, I think, why this task is focusing pretty much on the side aspect of the pure energy efficiency, because we know it could be counterproductive.
Mark, we have only 1 minute left, and I think there's one question which might be interesting for you to be answered. This is the question on your survey that you did with the users, you know, these 100 professionals all around the world. What is their perspective on how users accept control versus manual manipulation of lighting systems? Do they want to have everything automated or everything manual, or how do they deal with that? But shortly, well, because, yeah.
Yes. Okay, the first demand was simplicity, robustness. It has to work, because a system that doesn't work fails, right? There's a big frustration of system that works 90% of the time, but fail 10% of the time. That's, for me, something that fails, right? So there was a demand for overriding, which means having the occupants being able to keep control of the system. It's true. And that's confirmed, I think, the observers' comment, from what I understand. The pleasure of the comfort of the users was not always put forward by the building managers, you know, and it's a bit hard to make a large interview of building users. So it's true that this survey has been a little bit influenced by that.
Okay. Perfect. I thank the speakers very much. I liked all the questions. Thanks for raising them. Sorry if I was not able to address all of them. I wish you all a nice afternoon, and thank you for the participation. And I will hand over to Arabella for the last final announcements. Thank you from my side.
Yes, thank you very much, Bärbel, and thank you very much, of course, to our speakers and the audience for this really lively Q&A and for all the great presentations we heard today. We received many questions about the webinar recording and also the presentations. And as Bärbel mentioned already, the webinar is being recorded as we speak, and then it takes us a few days to edit up the recording, and it's going to be available both on the ISIS as well as the IEA SHC Solar Academy homepage, so you can rewatch the the webinar there. And also you can find the presentations that were given today on those 2 pages as well. And then from my team here at ISIS, and of course, I think I can also speak for the speakers and for Bärbel and everybody from the Solar Academy. Thank you very much for joining us today. I hope you enjoyed it quite a lot. I did for sure. And I'm now going to say goodbye and we're going to end the webinar. So have a great rest of the day, wherever you are around the world. And we are looking forward to welcoming you back on our next webinar soon. Bye-bye.